Hello students, welcome to my channel. To- Today I am here to teach you chemical reactions and equations, which is first chapter of cbse class 10. So today we will be studying about the chemical reactions and the chemical equations, so which is the first chapter of NCERT textbook. So there are some contents. Okay, the first so we'll study first, we'll go through what we are studying in the lesson today. So we'll study about some introduction of chemical reactions and chemical equations, and next we will study about chemical reactions. So we'll do some activities, that is some experiments, some 3 experiments to study that how a chemical reaction takes place. So what happens when chemical reaction takes place? So next we will study about chemical equations. So when a chemical reaction takes place, we have to represent that in a form of equation. So how we represent that in the form of equation, that is we will study about chemical equations, and next we will be studying how to write a chemical equation. So we will study how to write a chemical equation. So next we will begin with the introduction. Let's think what happens when we come across some situations in our life, in a daily life. Milk is left at room temperature in summer, iron nail exposed to humid atmosphere. Grapes get fermented, food is cooked, food get digested. So, in our daily life, we come across so many situations. That is, if it is a summer, if we leave milk out at room temperature, what happen is milk get curdled. This is what happens when iron nail is exposed to humid temperature, humid atmosphere. That is humid atmosphere in the sense both the presence of little water droplets and air. So when this iron nail is exposed for both water molecules and the air, so what happens? It get rusted. So grapes get fermented. So if you leave grapes out, so grapes after some days get fermented and start producing alcohol. Okay, what is fermentation? That is production of the alcohol. That is, grapes get fermented, that means they start releasing alcohol. Some alcoholic smell comes from those grapes. Food is cooked. So when you start cooking, you keep a raw rice with some water for boiling, and that get cooked after some time. Food get digested. So when you have food, will it get excreted in the same form? No, right? That get digested. So these are all some situations of a daily life where where what happens, where we see those initial substances, okay, that doesn't remain the same, they get changed. So initial nature of all the substances has changed. We can say a chemical change has occurred, and therefore chemical reaction is taken place. So when the initial nature of those substances, that milk get curdled, iron nail get rusted, grapes get fermented, or rice get cooked, or and food is also digested. So in all these situations, we never see the substances same as before. That is, there is some chemical change occurred in them. So when this chemical change has occurred, therefore some chemical reaction has taken place in it. If some chemical reaction happens, then only it is possible for a substance to change its nature. So we are wondering how this chemical reaction takes place. So this come to your mind, how might this chemical reaction takes place? So why is this milk getting curdled? Why is this iron nail getting rusted. So all these things come to your mind, how this chemical reaction takes place. So let us study how chemical reaction takes place. So what happens, that is changes, the chemical changes occurs. So when a chemical reaction takes place, what are the changes that happen or the possible changes that happens? Let us do some activities to show how chemical reaction takes place. So let us do some activities. So activities, that is experiments, to study how this chemical reaction takes place and what are the changes that occur when a chemical reaction takes place. So activity 1.1. So you can see in an image, so a spirit lamp is kept. Okay, you can see the images as I am going through the points. Take a magnesium ribbon of 3 centimeters long and clean it using a sandpaper. So we have to take a magnesium ribbon in the sense it is just like a strip of a magnesium. So which is we have to take some 3 centimeter long magnesium ribbon and clean it with the sandpaper. So using a sandpaper you can clean the magnesium ribbon and then hold it with a pair of tongs. Yes, you can hold that magnesium ribbon with a pair of tongs and burn that using a spirit lamp, which is happening in the image given there. Okay, there is a spirit lamp kept and someone is holding a magnesium ribbon using a pair of tongs near a spirit lamp. So what is happening? What do you observe? We can observe a dazzling white flame. Yes, a white flame leaving back a ash. Okay, you can see here how it is given back a ash, a white powder ash. So that white powdered ash, okay, that white powdered ash is nothing but the magnesium oxide. So magnesium, when you burn magnesium ribbon, that is getting converted into a white powder, that is magnesium oxide. So this is how the initial nature, that is the magnesium ribbon, doesn't remain magnesium ribbon after it is getting burned, that is getting converted into a white powder. That white powder is nothing but the magnesium oxide. Why this happens? So what is the reason for this? When magnesium ribbon will react with the oxygen present in the air, so when you are burning this magnesium ribbon, the oxygen which is present in the surrounding comes and reacts with the magnesium and that will form magnesium oxide. The white powder which is obtained after burning the magnesium ribbon is nothing but the magnesium oxide. So you can see here, so a burner is kept, again a tongs holding a magnesium ribbon. As you are burning, a dazzling light, that is a white flame comes and that will form a white powder, that is nothing but a magnesium oxide. So this happens due to oxygen reacting with the magnesium. So activity 1.2. So we saw, so let us talk about activity 2. Take some potassium iodide and lead nitrate in 2 separate beakers. So take 2 separate beakers and in one beaker you take potassium iodide and in other beaker you take lead nitrate. So you take the beaker containing potassium iodide and pour that in the lead nitrate solution. So what you will observe? So you will observe a yellow precipitate getting settled down. So as you can see in the image, so what is happening when you are pouring potassium iodide to a lead nitrate solution, a yellow precipitate or a yellow color is getting settled down. So here we can see initially both the beakers were colorless. As you are mixing up the potassium iodide with the lead nitrate, the color, you can see a yellow color. So there is a change in color. So you can tell here a chemical reaction has taken place. So in the previous activity we saw the change in the state, that is solid getting converted into a powder. Yes, a powdered form. Here you can see the change of colors. So in the next experiment, that is activity 1.3, we will take a conical flask. In a conical flask, take some zinc granules and you can add a dilute hydrochloric acid or sulfuric acid, and you have to handle this with care as we are using acids. So what do you observe? Okay, what do we observe when you add zinc granules? Zinc granules and the dilute acid. So it might be any dilute acid, that is hydrochloric acid or sulfuric acid. When you add this to zinc granules, what do you observe? That you observe some hydrogen gas is released. Okay, when zinc reacts with the dilute acid, hydrogen gas is released. And also you can touch the flask, the conical flask, and you can feel the temperature of the flask will change, because a chemical reaction is taken place. A chemical reaction is taken place between the zinc granules and the dilute acid. So when these reacts with each other, there is a evolution of hydrogen gas and change in the temperature. So in all these activities, that is activity 1.1, we observed that there is a change in state, that is the magnesium ribbon gets converted into magnesium powder, that is magnesium oxide, a white powder, that is magnesium oxide. And in the second activity, that is 1.2, we observed that there is a change in color when two colorless solution, so that is potassium iodide and lead nitrate, when these two reacts with each other, they form a yellow precipitate. A yellow color is seen. And then coming to the third activity, here we observe that when zinc granules react with the dilute acid, there is evolution of the hydrogen gas, and also there is a change in temperature of the flask. Yes, there is change in temperature of the flask. From all these activities, we can come to a conclusion. So we have observed from the observation of the above experiments, we saw that how chemical reaction takes place and what happened when it takes place. So all these activities we saw. Yes. So what happened? What happens when these chemical reaction takes place? Either there is a change in state, or change in color, change in temperature, or evolution of gas. So all these things are possible. That is, the initial nature of the substance doesn't remain the same. It gets changed when chemical reaction takes place. So either it might be change in the state, change in the color, change in the temperature, or the evolution of gas. So in this chapter we will be studying about various reactions and their representation. So till we complete the chapter, it is all about the reactions and equations and how do you represent these chemical reactions. So now we have seen that a magnesium ribbon is forming magnesium oxide when it reacts with the oxygen. So how do you represent this reaction? So in the whole chapter you will be studying about how all the chemical reactions and how do you represent them. So chemical equations. So in activity 1.1, we saw magnesium reacts with oxygen and forms magnesium oxide. Writing this in a sentence is a long form, but we write it in a short form, that is word equation. So writing huge, like writing magnesium burn reacts with oxygen present in air and forms a white powder, that is magnesium oxide. This is a bit long, okay. Writing a reaction in a sentence is a long form, so let us make it in a short form, that is a word equation. So magnesium plus oxygen, so magnesium plus oxygen, you are using a plus mark. Yes, plus mark in between. Your magnesium and oxygen are the reactants on the left hand side, and an arrow in the between. Yes, an arrow in the middle showing the products. Okay, what you have obtained after the reaction taking place, that is a product, magnesium oxide. The white powder which you obtained, that is the magnesium oxide, and that is the product. The left hand side is the reactants and the right hand side are the products, and a arrow mark is used to show the reactants and the products. In between the reactants and the products, we use a arrow mark, and a plus mark is used if there are more reactants. To add the reactants, you are using a plus mark on both the sides. This is how you write a word equation. So next coming, writing chemical equations. How do you write chemical equations? So there is still more short form of writing chemical reaction. So a word equation we saw. Yes. So how this word equation is a bit long form. So even we can convert this word equation into a shorter form, that is using chemical formulae of the chemicals. So the chemicals have some symbols like magnesium Mg, oxygen O, hydrogen H. Yes, so by using these chemical formulae, we can make the equation even smaller. So we'll take the same example of a magnesium reacting with oxygen to form magnesium oxide. Mg plus O2, that is, you can see Mg is for magnesium ribbon and O2, that is for oxygen present in air, which gives you magnesium oxide, MgO. Yes, MgO. So now you have to count this is a chemical equation. How do you write in a shortest form? That is by using the chemical formulae of the chemical, that is the reactants and the products. Count the numbers of atoms on both the sides of the reaction. So when you write a reaction, you need to count reactants and the product, the atoms, number of atoms of the reactants and number of the atoms of the products. So when you are counting this, if both the sides the number of atoms are equal, yes, then the equation is balanced. If not, then it is imbalanced or unbalanced equation. So you can see here magnesium, there is one atom of magnesium. There is one atom of magnesium and two atoms of oxygen in the reactant side. But coming to the product side, you have one atom of magnesium. So one atom of magnesium on the product side and one atom of a magnesium on the reactant side. Magnesium is balanced here. Oxygen, you have two atoms on the reactant side but only one atom on the product side. That means this reaction is imbalanced. This is a skeletal chemical equation for burning of magnesium in air. Okay, this is nothing but a skeletal chemical equation. So balancing the equation is also very important. So that thing we'll be studying in the next class. So for today, you remember that we have studied about chemical reaction. So what happens in the chemical reaction? When chemical reaction takes place, there is change in the initial nature of the substance. Either that is change in the state, change in the color, change in the temperature, or evolution of gas. So, and we also came across chemical reactions, chemical equations, how to write a chemical equation, the word equation and a skeletal chemical equation. So, in the next class, we will be studying about balancing the equations. So, thank you.